Let's talk about how to build better tools for your agents, because the effectiveness of your agents is really dependent on the tools that are available along with the intelligence of the model. So I'm going to break it down and we're going to look at some practical insights. And by the end, hopefully, it will make you rethink how you think about tool implementation. Now, the idea for this video came from this blog post from Anthropic, writing effective tools for agents with agents. So we're going to look at key findings and some practical insights. But before that, we need to actually think about how software engineering is changing with agentic systems. So in traditional software engineering, you implement the core functionality of a tool by wrapping it around in a function. Now, these are deterministic systems. So you provide an input, you expect a deterministic response. With tools, it's actually changing. Normally, the input is a natural language query. Then the agent, based on its own plan, is going to decide the steps it's going to take. It can either make a tool call, use its internal knowledge, or even ask you a follow-up question. And every time you ask the same question, you are going to see different steps the agent comes up with. And normally, these agentic systems are part of the traditional software engineering stack. So you really need to rethink how you implement these systems. So the blog post itself talks about 4-step process on building good tools. Our focus is going to be mainly on what are the key principles around writing better tools. But for the sake of completeness, you want to first start with an initial prototype that is going to implement the core functionality. Then you want to run evals on the tools that you implement. Then you want to collaborate with a coding agent. So basically using the intelligence of the coding agents to help you improve your tool description and tool implementation. And at the end of the day, you want to run evals on it, because if you can't measure it, you can't improve it. And this is normally an iterative process. But when it comes to implementation of the tool themselves, here are the key principles I'll recommend to keep in mind. The first one is choose the right tools to implement. And don't worry, we're going to talk about details of all of these. Then make sure that you are able to group different tools together. This will help the agent select better tools. Then we're going to talk a lot about context engineering. So you want to make sure that the input to the tool is meaningful. Also, the return from the tools are some meaningful context that we can feed into the LLM. That will also brings us the token efficiency, because we don't want to just fill up the context of the model with useless information. Prompt engineering is not dead. So we're going to talk about how to effectively prompt engineering tools descriptions that are going to be helpful for the LLM to select the appropriate tool. And then more tools don't always lead to better outcomes. As with traditional software engineering, small refinements yield dramatic improvements. Next, we're going to talk about each one of these with more concrete and detailed information. But I want you to look at this flow. So let's say you have a task that is provided to the agent. The agent can select a number of different tools for each of the subtasks. Now, the input and output of the tool is going to add to the context window of the model or the LLM or the agent. And we'll need to carefully think about how to preserve only useful information in this context window. A really good example of good tools for AI agents is BrowserBase. They enable web browsing capabilities for your AI agents and applications. So think of them as a cloud platform that lets you host tools like Puppeteer and Playwright that can interact with your AI agents. And they are also the kind sponsors of today's video. It's extremely scalable, fast, and secure platform that lets you create your own custom agents for browser automation. They have pre-existing browsing tools. It enables workflow automation and can also let you web scrape data from websites. But the feature I like the most is called Stagehand. This is their open source AI browser automation framework. So this enables browser automation by defining actions and then assigning tasks to the agents. And this comes with a very powerful SDK that you can start using in your own applications. This SDK has a number of different existing agents, including a computer use agent, and is fully compatible with Playwright. So Browser automation is extremely easy with Stagehands. This lets you interact with Playwright through natural language. So for example, if you were to go to a web page, this is the command that you're going to use. Or if you want it to take an action, you can just describe that in natural language. Also, it enables computer use agent. And the best part is that if you want to scrape data from any website, you can define your own custom schema. The agent is going to go extract that data and return it to you. This is an extremely useful tool for agents that are going to be interacting with your web browser. Do check them out. Link is going to be in the video description. Now, back to the video. So the first principle is choosing the right tool for the task. Now, more tools does not mean you're going to get better outcome. Actually, they say that they have seen a common error that people just wrap existing software functionality or APIs in a tool and present that as a tool to the agent. That's not how you want to think about implementing your tools. You want to think about the context window of your LLM. So a tool can have a cascade of multiple different operations, and you want to just generate meaningful outcomes that the agent can use. Okay, so here's a very simple example of address book search. In traditional software engineering, you could implement a system that is going to load all contacts in the memory, then iterate through each contact, and if there is a match, that results is going to be returned to you. Now, you can write multiple different tools for this if you want to use this with an agentic system. So for example, there's one tool which is going to be list contacts. It's return you all 500 contacts. Then if you think about it, is let's say each contact is 50 tokens, you're looking at about 25,000 tokens. Then you can have either the agent go through each one of them token by token, or you might have another tool which go through it token by token, right? At the end of the day, you are going to fill up the context window of the agent with useless information. Now, instead of this, a good approach would be a tool that searches using the traditional software engineering setup and only return a very small subset of contacts that it thinks are meaningful. It could be just a simple rack system. And then you pass on that result to the agent because the agent is just looking for that one or two context. So the way you think about it is that when you're designing tools, you should think about how humans interact with these tools. So for example, you want to have search mechanism, not browse, filter, don't scan, and navigate, don't iterate on things. So here are some more examples. Instead of implementing list users, list event, create events, like 3 different separate tools, consider implementing schedule event, which finds availability and schedule an event. And essentially, you are wrapping multiple different steps inside a single tool. Another example is instead of implementing read logs tool, consider implementing search tool, which only returns relevant logs and some surrounding text. Again, search, don't scan. Another idea is namespacing your tools. So you want to group similar tools together. Now, right now, we have a dozen of MCPs that an agent can have access to, and each one of them might be implementing very similar functionality. Now, if the agent has to decide which tool to pick, there is a high probability it will get confused. So here's a very simple representation. Let's say there are a number of different MCP servers. Each one of them is implementing search, create, update, delete, so on and so forth, right? Now, without grouping them together based on the MCP server, if they're using similar names, the agent is going to get confused. However, if you group them together, so for example, there's a namespace for Slack messages, then there are tools specific to Jira. You add these prefixes to each of the tool, then it's going to really help the agent determine which tool to use for which task. They have a very interesting insight. So there seems to be a difference if you use a prefix or suffix when it comes to the tool use evaluation of the agent, right? So you probably want to experiment with both. So put the namespace before or after the tool name and see whether it's going to have any impact on the tool usage or tool call performance. So even though these systems are getting smarter and smarter, they can be tripped by these very small nuanced changes. Okay, so the next pattern is, how do you think about returning information from a tool? So whenever you have a tool call, you're going to get results. So what exactly do you add in those results? Now, the common logic is going to be add as much information as possible, but that can actually backfire. So they say tool implementation should take care of to return only high signal information back to the agent. And you want to make sure that that information actually makes sense. So instead of returning low level technical identifiers like UUID or maybe some encrypted image URL, you want to return fields like name, image URL, which are more descriptive. Now, there are cases in which those low-level technical identifiers can also be helpful. So you want to return structured outputs or structured formats in which you preserve both low-level and high-level details. According to them, agents tends to grapple with natural language names, terms, and identifiers significantly more successfully than they do with cryptic identifiers. Now, another question, should you return it in XML format, JSON, Markdown, right? Now, that really depends on how your models were trained. Claude, for example, loves XML format, and OpenAI models also tend to like XML now. They used to be pretty good at JSON, right? So you actually want to look at the model that you're using, and based on that, you decide what is going to be your return data format. Next, you want to think about optimizing tool response in terms of the number of tokens that you're returning. Again, context management is going to be critical. So optimizing the quality of context is important, but so is optimizing the quantity of context return back to the tool as a response. Now, they suggest for longer context that is going to be returned, use pagination, range selection, or some sort of filtering or truncation mechanisms. By default, code restricts tool responses to 25,000 tokens. Now, keep in mind, if you're going to be making, let's say, 12 tool calls in order to perform an operation, this is going to add up. So you want to be really careful about how much information you actually want to return. One way is to simply truncate responses. For this, there are a few strategies. For example, you can directly encourage agents to pursue more token efficient strategies like making small and targeted searches instead of a single broad search for knowledge retrieval tasks. Very similar to the context book example that we talked about. Now, last but not the least, prompt engineering for tool description. This is a piece that I often find people ignore, but I think it needs a lot more attention. So the way to think about this is, if the agent is going to select a tool, it's going to mainly look at what the description of the tool is and what are the input outputs. You want to pay close attention to what the tool is supposed to do. Also, properly name the input variables and the outputs from the tool, along with the specs of the functionality. Now, a very easy way of thinking about this is that if you hire a new intern, what type of information they will need, assuming that they don't know anything about your system or your setup, right? So with that in mind, you want to also provide specialized query formats, definition of niche terminologies, relationship between underlying resources, and make it explicit. The idea is avoid any sort of ambiguity where the agent will have to make any assumptions. This is critical. Communication is the main key between a really good agentic system and a failed agentic system which is confused on tool selection. The rest of the article mainly focuses on how to improve these tools with agents. The idea is very simple. You come up with the initial implementation of your tool, then you need to come up with real world evaluation test cases. Now, this is critical because a lot of times what I have seen is that people will come up with synthetic examples which have nothing to do with the actual real world use case. And it's very sad because these systems do really well on those synthetic evals, but when it comes to real world tests, they fail. And the reason is that when you're building these test sets or eval sets, you are not actually capturing the real world use cases. So if you follow all the recommendations, then if you want to iterate on those tools with the agent, you want to provide as much information as possible. So that will include all the documentation that is going to be necessary. And the idea would be you come up with an eval set where you can test the agent. Also, you want to make sure that you want to test it in complex scenarios where you combine multiple different tools instead of testing tools in isolations. So for example, here's a weak task for test. So if you ask a tool or an agent, schedule a meeting with a person next week, right? The agent might just select that one tool and schedule the meeting. However, your test should look something like this. Schedule a meeting with Jane next week to discuss our latest, let's say, a project. Attach the notes from our latest project planning meeting and reserve a conference room, right? Now, this will involve the agent to plan and then select multiple different tools in order to accomplish that plan. This is probably a more realistic real world test case rather than having a very simple single tool selection example in your evaluation data set. And again, this is critical. I have seen a lot of failures where people run simple eval tests while they're building their systems, and those systems fail because of the complexity in real world. After that, you can have an agentic loop. So basically, with the given set of evals, you run this in a loop, you gather the information. Also, you're going to look at the feedback that the system generates, and then you use that feedback along with the agents to improve upon your tools. Now, based on their internal tests, they show that if you use the agent to improve your tool, you can actually get substantially better performance. Now, do let me know if you want me to create more detailed videos on the evaluation setup. There are a couple of notebooks. I'm going to put them in the video description. But I hope you found this video useful. And if you need help with building better systems, you can reach out to me. Details are going to be in the video description. Anyways, I hope you found this video useful. Thanks for watching. And as always, see you in the next one.